So the program I like to use for my PCB designing is a free one available online called Circuitmaker. It's by the company Altium. Other options, of course, are KiCad. I've tried using that, but I haven't spent enough time with it to be able to become comfortable with it. So this is the software that I use. So it's very easy. Just start a new project, go up to File, and then New Schematic, which brings you to this view here. Now, one thing about designing with this particular program, it may be true of other programs as well, but it really makes things easier if you know exactly what components you're going to be using. If I press C on my keyboard, it'll bring up the component selector, and you can have a favorites or just from all parts that it has a library of. And I know, because I've already got these LEDs, I know the part number of them, which is this incredibly long part number here. And it recognizes it, but what we see is it has no symbol and it also has no footprint. So that's not much use. But with these long part numbers, often you're able to shorten them. I happen to know that this first part is the main part of our description of this particular LED. So if I just do a search for this shorter section, sure enough we come up with a whole number of different ones, different colors, everything else. But we've got this first one, we've got the symbol, and if I scroll down here, we have, or we should have, a footprint as well. Yep, it's got a footprint. So we shall select this, even though it's not exactly the right version of the LED. It's in the same family, it's the same size. So I can then just hit place. And so we can place these in, and you can just place multiple of them, and then do the same for the other components, which I will do as well. So after a long and very boring process, I've managed to get the schematic put together. So what we have here is our 18 volt side of the board. So we've got 6 diodes in series, and of course there's 10 of them, 10 rows of them, each with their own current limiting resistor. And then we've got our 12 volt side of the board over here with just 4 LEDs in series, again each string with their own current limiting resistor. And then we've got power connectors. All the LEDs and resistors are all surface mount devices, whereas these board connectors are through-hole devices. Whether or not you use these actual connectors is kind of irrelevant. The fact of putting them on the board gives you the through holes that you can then just wire directly to if you want to, or you can use these terminal blocks for powering it. So after doing all of this, I then generated and made a circuit board. We'll have a look at that. This looks a bit overwhelming at the start. Of course, it's a double-sided board. This top side is the 18 volt side. So we have our LEDs, 6 of those, and then the resistor up at the top. And then of course repeated 10 times across the board. As you can see, we've got our connectors on each of the 4 edges, so that should you want to put 2 of these sort of side by side, then they can just be linked through just with a couple of wires, or end to end, in whatever configuration you want it. If I just turn on the 3D view of this, it makes it a bit easier to see. So you can see, don't worry about this connector up here. It appears to be facing the wrong way. I just had to orient it on the board that way so that we had the ground being on the same sort of pin, 12 volt and 18 volts, so that when you do put boards side by side, they can just be wired directly without having to cross wires over. So this is the 18 volt side. Then if we flip the board over, we can then see, just zoom out a little bit, we can see that we've got just 4 LEDs in a series. Of course the resistors up at the top there. Little mounting holes, almost forgot to put those in. I really should put them in at the start, I keep forgetting, but such is life. So now that this is done, what we need to do now is to generate the gerbers, the gerbers, whatever you call them, the files that we're going to send to the PCB manufacturer. So we do this ironically up in the project tab, not in the outputs tab. In the project tab, you then go to generate outputs, and then you can tick off what you're wanting to generate. So you can generate a bill of materials if you want, schematic prints, actual prints of the PCB itself, even 3D views, but we're not bothering with any of that. All we need for the PCB manufacturer that I'm going to be using is the Gerber files and the drill files. So you're able to go in and configure them, whether you're on inches, whatever. If you go to your PCB manufacturer's website, they'll often have a list of requirements. The one that I'm using, I think, is going to be JL PCB, and so I've set this up with their recommendations. They recommend all of these files, embedded apertures, whatever that means, and then these settings also. Same with the drill format settings on the page that have been filled in. And then it's just a case of clicking generate and waiting while it does its thing. So once that was generated, I was able to download the Gerber file, which contains both the drill and the Gerber files. Is it Gerber? Gerber? I don't know. But once that's done, you're able to go to your favorite PCB supplier. I'm just using JL PCB. They're not a sponsor or in any way connected with the video. I'm paying for this. And then you upload your Gerber files, and now you can see. So now we can go through and select our various options. So we are 2 layers, dimension 75. I was off by 0.5 millimeter. Oh well. You select the quantity that you're wanting. It's just a single PCB, the standard 1.6. I'm wanting white, black silk screen, surface finish. You can have gold plated if you want. Look, watch the price jump up. Suddenly a lot more expensive. Or if you want to go eco-friendly, lead-free, it also jumps up. So 1 ounce copper, price for 2 ounce, way more expensive. Don't need cool fingers, don't need to confirm production file. We can do the fully test, the not test. Does that make a difference to the price? Absolutely none. With no castellated holes. I want to remove the order number, and I'm also, this is going to be a new experiment for me, I'm going to have a stencil. I don't want framework because that adds, doesn't add too much. Oh well, we'll have a framework. Yeah, that'll do. That size will do. The other one would be just slightly too small. Stencil sides, so top and bottom, so it's a single stencil, both designs on it. Because otherwise you end up paying double if you want 2 different stencils. Just the one. I'm just going to have it just the bog standard. This is just an experiment. And so that's pretty much that. And so then it'll just be a case of saving that. and then going through the checkout process. And you may understand that I won't be filming that. That about wraps this video up. I'm going to leave it there. It may be a little while before I do the next part of this, because obviously I have to wait for getting these PCBs supplied. Thank you so much for watching. We hope that this has been somewhat educational. I'm certainly learning a lot. And we'll see you on the next one.